Black body radiation. So what is the ideal black body? Ideal black body is a body which can absorb all radiations as well as it can emit out all radiations, that means all of all wavelengths, a good absorber as well as a good emitter. So a black body radiation phenomena was explained successfully by quantum theory given by Planck. So let us try to figure out how it was different from initial electromagnetic theory. If initial electromagnetic theory was a true one, then all always the color of a heating object will remain the same. But what used to happen is, as the temperature of electromagnetic body of a heated body was increasing, the color used to change. That means the emission of the radiation depends on the temperature of the black body. If temperature is less, then radiation of lower energy was emitted. If temperature was high, then higher energy radiation was emitted. That means that energy is emitted as per the temperature. So the radiation emitted depends on temperature of the heated body. Alright. So there was a graph plotted on the basis of wavelength of the radiation emitted and the temperature. If you like to see, it is like this. If temperature was lower, then lower energy, that means a graph having lambda maximum. Let us say this lambda max is lambda 1, this is lambda 2, and this is lambda 3. So what do you see? Lambda 1 is this, lambda 2 is this, lambda 3 is this. You know energy is equals to hc by lambda. That means if lambda is more, then energy is less. Inverse relation between energy and wavelength. So let's see. As you move away from the origin, lambda is increasing, that is wavelength is increasing. So wavelength is increasing, that means emitted energy is less. So that's why you see for lambda 1 the wavelength is less, so energy is high for lambda 1. And in case of lambda 3, wavelength is high, so energy emitted is low. Energy emitted is low, so intensity is what I hope you know intensity. If you do not know, let me put it across. Intensity is number of photons emitted per unit area per second. Let me repeat it. Intensity is number of photons emitted per unit area per second. So if energy emitted is more, number of photons emitted is more, then intensity will be more. And when it will be more? When total energy is more. Total energy more means wavelength is less. Wavelength is less, so energy emitted is more. So let's see where is wavelength less. So lambda 1 is least, lambda 1 is least, so energy emitted is more, so intensity is highest. Intensity is highest. Lambda 3, lambda 3, lambda 3 is maximum, lambda is maximum, so energy emitted is small. Energy emitted is small, so intensity is also small. So that is what is explained in this graph, that the energy of emitted radiation depends on the temperature. Higher the energy emitted, higher will be the temperature of the body. If you ask me which temperature is more, the temperature of lambda 1 or the temperature of lambda 3, I will say energy, where energy is more, for lambda 1. So temperature according to me, T1 will be greater than T2 than T3, because energy of 1 is greater than energy of 2 than energy of 3. So intensity of 1 is more than intensity of 2 than intensity of 3. So we have explained everything about this graph on black body radiation.